Good morning everybody, it's Ramachandra from Civil Maths Concepts channel. From this channel I have released 15 videos till now on various topics of advanced mathematics useful for CSIR, GATE, UPSC and IIT JEE Advanced and Mains. In this lecture I will be discussing about Kronecker delta and Levicivita symbols being used for solving many vector algebra problems and vector algebra identities like triple products, double products, cross products and dot products like A cross B cross C is equal to B CA minus CAB. This we will prove in seconds using the Kronecker delta Levicivita symbols. I am an IIT alumni. I welcome everybody to my channel and I wish best of luck to everybody. Please listen to my lecture. Welcome everybody. Today, as a special lecture, I will talk about Levicivita symbol and Kronecker delta. It's Ramchandra from Civil Maths Concepts. In the continuous lectures on mathematical concepts, today I will take up some important concept of mathematics required in linear algebra and also vector algebra. Vector algebra. It's a very important concept. Kronecker delta and Levicivita symbol. In matrices, you might have seen multiplication of 2 by 2 matrix, 3 by 3 matrix, which I have explained in my linear algebra lectures. And if you recollect from there, you can see we'll write A dot B is equal to A1 B1 plus A2 B2 plus A3 C3, where A1, A2, A3 are the components of vector A and B1, B2, B3 are the components of vector B. For the benefit of everybody, I just give a simple brief on vector representation. Let us take (3D) space where we take a point P with coordinates xyz, and let us say origin is O, and when you connect origin with the point OP, vector OP is the positional vector of point P XYZ. This positional vector P XYZ OP can be written as x into I plus y into j plus z into k, where I, j, k are unit vectors in x, y and z directions. Now, we understood what is a positional vector. Let us take 2 points P and Q. Let us take again space. This is x-axis, this is y-axis, this is z-axis. Let us say one point P, it is x1, y1, z1, and another point Q, it is x2, y2, z2. Origin is O. When you connect O and Q, it will be position vector of OQ. OQ is equal to position vector of Q. That is equal to R2, let us say. OP is equal to position vector of P, that is equal to R1. Then when you connect P and Q, what happens? What will be PQ? PQ is equal to distance vector. From vector algebra or basics of vector, OP is equal to minus PO and OQ is equal to minus QO. Because a vector has both direction and magnitude, if the direction is changed, the vector will get the negative sign. Now, for PQ, we can write, put a point O in between. What happens? It will be PO plus OQ. In between, this is the common point. That means it comes from PO and OQ. PO plus OQ gives PQ. Then what is PO? PO is nothing but minus OP. That is equal to minus OP plus OQ. What is OP? That is R1. What is minus OP? Positional vector minus R1. What is OQ? OQ is plus R2. That means PQ is equal to R2 minus R1. PQ is equal to R2 minus R1. Many people have many different definitions like tail, and head. Instead of going through all this, you take a reference point O. From that, you go on writing, adding and subtracting the vectors. and when vector is opposite to another vector means that is negation, and you add the negations and all those, you will get the result. It's a very simple method. Because if you go for tail, head, tail, what happens in that? You may get confused. The directions, everything you will get from PQ is equal to PO plus OQ, that is equal to minus OP plus OQ, that is equal to minus R1 plus R2, that is equal to R2 minus R1. This is the result. Simple. And once you know the PQ, you can get OP also, we can get OQ also, you can get QO also, you can get PO also. This is a very simple method. In this method, you can find out the position vector and distance vector. Now we will go to basics of this dot product and cross product of two vectors by using Kronecker delta and Levicivita symbols. What is Kronecker delta? Kronecker delta can be defined as the dot product of two unit vectors. Kronecker delta. The symbol is delta because it is a Kronecker delta. The symbol is delta. I can call it as delta Ij or delta Lm or delta PQ. This Ij, Lm, PQ, these are all only a number. The subscript of the element in a matrix or subscript of a vector, element of a vector. Now, what Kronecker delta says, definition, delta Ij is equal to 1 if I is equal to j, is equal to 0 if I is not equal to j. And this delta Ij is nothing but dot product of two unit vectors. Unit vector Ei dot Ej. This is equal to 1 if I is equal to j. This is equal to 0 if I is not equal to j. Let us elaborate the meaning of it. Let us say there is one circle and there is a cycle 1, 2, 3, or we can call it as X, Y, Z. Just for the sake of convenience, I am writing this. Or we can say I, J, K, where I, J, K are the unit vectors in X direction, Y direction and Z direction. If I is equal to J, that means what happens? My Kronecker delta, delta ij is equal to unit vector E1, Ei, Ej will become E1, E1, E2, E2, that is equal to E3, E3. I can say E1. I can even call it as in the x direction unit vector I. I dot I is equal to j dot j is equal to k dot k is equal to 1. Kronecker delta delta ij is equal to 1 because it is the dot product of the two vectors. The vectors in the orthonormal vectors at 90 degrees angle between them, ij and k, is I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. If delta ij is equal to, here I is equal to j. It is a proof I am giving you. Proof of the Kronecker delta. Next, delta ij is equal to ei ej, because dot product of two vectors having subscripts of I and j, where I and j are numbers. Let us say it is E1 dot E2. What is the corresponding value of E1 for 1 and 2? The corresponding value of unit vectors is I and j. I dot j, which is nothing but from definitions I dot j is ij cos theta, that is equal to ij cos 90, that is equal to 0. That implies when I is not equal to j, Kronecker delta delta ij is equal to 0. That means what is the Kronecker delta value? From definition, Kronecker delta delta ij is equal to 1 if I is equal to j, is equal to 0 if j, where delta ij is the dot product of the two orthonormal vectors, unit vectors. This is the definition of the Kronecker delta. Now, let us talk about Levicivita symbol. What is Levicivita? These are only definitions. Please take them as definitions only. Don't get confused. Levicivita is epsilon I j k. Please see the order. Levicivita symbol is epsilon I j k is equal to one. If there is a permutation in the cyclic order of cycle of I j k or 1 2 3 or x y z followed, then in the clockwise direction. This is used for the cross product. You just see. This is a circle. This is 1 I x. This is 2 j y. This is 3 k z. If it goes in the clockwise direction, this value will be positive. Epsilon ijk will be plus 1 if it is in the clockwise direction. Ijk is this ijk. If it is in the anti-clockwise direction, like ikj, now this will be epsilon ijk is equal to minus 1 if cycle is anti-clockwise. Cycle is equal to anti-clockwise. Anti-clockwise cycle means what it means? That is, if something is like 1, 3, 2, something is like x, z, y, etc. This value will be 0 if the cycle jumps one value or otherwise. There is a cycle jump. Instead of 1, 2, 3 in the clockwise, 1, 2, 3 in the clockwise. If you have 1, 3, 2, then that is anti-clockwise. If there is a jump, if there is a repetition of the number, there is a jump, then otherwise this value is 0. For example, if there is any confusion regarding epsilon ijk, from the basics of the cross product of A cross B, what it will be? I, J, K, A1, B1, A1, A2, A1, A2, A3, B1, B2, B3. How it is written as? I into A2, B3 minus B2, A3. A2, B3 minus B2, A3 minus J into A1, B3 minus B1, A3 plus K into A1, B2 minus B1, A2. This is the cross product. Now, the same cross product can be written in the form of Levicivita symbol as A cross B is equal to epsilon ijk aj bk. Please, this particular formula, wherever we said ijk and jk, these are all numbers. For a 3 by 3 matrix, you are able to write very easily the value of A cross B. But a 100 by 100 matrix, for a 100 by 100 vector, how can you write A cross B for many number of vector spaces? Then this is the way we have to write. For a 3 by 3 matrix, this can be extended to any amount of vector spaces. This can be extended to any number of matrices, columns and rows. Now, this is for 3 by 3 vector space or matrix. Now, you just see A cross B I have written as epsilon ijk, which I have defined already, and aj. Here I left I and I put j here for A and for k here for B. Please try to follow this very carefully. Now what is the value of epsilon ijk? If it is in the cycle in clockwise direction, it is +1. If it is in the anti-clockwise direction, if it moves in the anti-clockwise direction, the value is negative. Then can we write the permutations or combinations for epsilon ijk? Let us write now. Epsilon ijk is equal to +1 for cycle 1, 2, 3 is equal to -1 for 1, 3, 2. Why it is -1? You just say this is the cycle. This is 1, this is 2, this is 3. For 1, 2, 3 it is positive clockwise. For 1, 3, 2 it is negative anti-clockwise -1. This is equal to +1 for 2, 3, 1. 2, 3, 1 means it is positive clockwise, and this is equal to -1 for 2, 1, 3. 2, 1, 3 means this is negative anti-clockwise. This is equal to +1 for 3, 1, 2. You just see from 3, 1, 2 it is positive clockwise, and it is equal to -1 for 3, 2, 1. 3, 2, 1 it is negative. This concept should be very clear. Epsilon ijk. Once epsilon ijk values are already there and delta ij values are there with you, then we can represent cross products and dot products of any vectors. 3 vectors, and we can get the triple product, box product. We need not by heart. For example, the value of, I can say, for example, the value of a prove that from Levicivita symbol and Kronecker delta What we have to prove? A cross that scalar product, vector product properties we can prove using Kronecker delta and Levicivita symbols, concepts we can prove very easily instead of by hearting the things. Let us say triple product A cross B cross C is equal to B into C dot A minus C into A cross B. This part we have to prove. Not only this, many products, many vector products, because vector products, scalar products and dot products using ABC, ABCD vectors, number of vectors, they are being asked in IIT JEE and also in GATE and also in JAM, IIT JAM and also in CSIR. These properties, how to prove them? To prove these properties in a traditional manner, it will be very, very difficult to go ahead. Whereas using Kronecker delta and Levicivita symbol, will be able to prove them very easily. Will be able to prove them very easily. And before proving this, because it is one of the typical questions which either we will be able to prove in this class or in the next class, while dealing with the Levicivita symbols and delta, Kronecker delta, because it cannot be completed in one single class. This typical product may be proved in the next class, but however, we'll start with the simple definitions and simple proofs. Before proving this particular question, we have to define another thing. Another Levicivita symbol using Kronecker delta, we have one statement, very important statement, epsilon I j k into epsilon I p q is equal to, I told you the subscripts are only numbers, don't worry, cyclic numbers, delta jp. Please, this is the relation between Kronecker delta and Levicivita symbol. Once we start solving the problems, we will be able to understand what it is. Delta jp, delta kq minus delta jq. Please write the way I am writing it here. Delta kp. This is very, very, very important equation relating Levicivita symbol and Kronecker delta. You just see here. You just try to understand how I related. I related first. This is delta jp. How delta jp we have got? Just see. Levicivita symbol, first symbol J, second subscript is joined with, J is joined with P and delta is written. Here K is joined with Q and delta Q is, KQ is written. Now JQ, it is when in a sequence I is left over, J is mixed with P, K is collaborated with Q, JP, KQ, when we have written deltas, that is positive. When we reverse the direction, what happened? J is the second symbol is collaborated with not the second symbol, it is the third subscript of the second epsilon, then this JQ, it has attracted a negative, minus delta JQ. Then this K is with P, just see. Then also it is minus. That means delta JP, delta KQ minus delta JQ into delta KP. This can also be for convenience purpose. Some people in some books it is written as, you can use this also, epsilon IJK. IJK and all these only numbers. Don't worry about them. ILM. You just see. Here also, this I is here. I is common in both. First one is common in both. This is equal to delta JL. Instead of P, it is L. That's all. Delta KM minus delta JM delta KL. It can be written this way also. In some books, it can be LNN, PQR. This can be anything. This is very, very important relation between Kronecker delta and Levicivita symbol. Now, by using this particular relation, we can prove any property of the vectors. Like A cross B cross C is equal to B into C dot A minus C into A dot B. These things we can prove very easily using this symbol. For example, if you have forgotten, many relations are there, triple products are there, double products are there, cross products are there, and dot products are there, you are confused, then use these two relations, Levicivita symbol and Kronecker delta, the relation between them. With one equation, you can solve any relationship. Very simple. You can solve any relationship with one symbol, one equation, using the relation between Kronecker delta and Levicivita symbol. Now, there is something called Einstein convention. As per Einstein convention, we write A dot B for the dot product. This is I is equal to 1, 2, 3 sigma AI BI. That is equal to A1 B1 plus A2 B2 plus A3 B3. This is the dot product. That, as per Einstein convention, we can write it as AI BI, dropping the sigma symbol. We can drop the sigma symbol and we can write it as AI BI. A dot B is equal to AI BI. This is Einstein convention. Now, our Einstein notation, people call it as Einstein notation. Now, we'll try to prove the value of A dot B, A cross B. A dot B we have already defined with Einstein symbol, Einstein notation rather. A cross B we try to prove the value of, or we try to get the value of A cross B, or we try to prove the value of A cross B by using Kronecker, delta and Levicivita symbol. Let us see. Let us take A is equal to, vector A is equal to A1I plus A2J plus A3K. B is equal to B1I B2J plus B3K. This is I am doing it only for understanding Levicivita symbol and application of Kronecker delta. I have taken a very simple exercise so that you can appreciate how this can be used for other vector products, triple products, box products, and the other complex products which are useful in electrical fields, magnetic fields, and the definitions in electrical engineering, electronics engineering, civil engineering, tensors, and mechanical engineering systems. These are all how they are used. There are all multiple big systems will be available where we can apply this Levicivita symbol and Kronecker delta relationship. Ultimately to find out, to solve major complex equations. I am using it for A cross B for a 3 by 3, that is IJK space. And what is the answer for this? It is because it is a very simple one, we will be able to write it as a matrix I, J, K as I written earlier, A1, A2, A3, B1, B2, B3. Can I apply Levicivita symbol and get this answer? It is like this, I into A2, B3 minus B2, A3 minus J into A1, B3 minus B1, A3 plus K into A1, B2 minus B1, A2. This is a very simple one which I am proving. The bigger ones we will do in the next class. And this you see, by using Kronecker delta and Levicivita relationship, how we can write the above. A cross product, please remember this, a cross product A cross B is equal to epsilon I J, K. You leave the first one and you write A, J, B, K. This is what is the A cross B product. As per, it's a very important equation. Please remember this. A cross B is equal to epsilon ijk aj bk. This I is left over and j is attributed to A and k is attributed to B in a cyclic sequence. Now, I have seen from Einstein notation that aj bk ai bi is nothing but a summation. Now let us do the summation here. If I do the summation, what happens? What are the various permutations and combinations I have? Epsilon permutations and combinations here I have. For 3D, epsilon 1, 2, 3 is equal to plus 1. This is the cycle. Please remember. This is 1, this is 2, this is 3. Epsilon 1, 2, 3 is equal to plus 1. Epsilon 1, 3, 2 is equal to minus 1. In the reverse direction, epsilon 2, 3, 1 is equal to plus 1. Epsilon 2, 1, 3 is equal to minus 1. Epsilon 3, 1, 2 is equal to plus 1. Epsilon 3, 2, 1 is equal to minus 1. Now when you expand this equation, A cross B is equal to epsilon ijk, I is left over, aj, bk. It is a summation. When a cyclic summation is done, this will be epsilon 1, 2, 3, A2, B3. J is replaced by 2 and K is replaced by 3. Next, epsilon, because all the 6 combinations I have to write. Epsilon 1, 3, 2, summation of all the 6 combinations. Epsilon 1, 3, 2 will be A3, B2. 1 is left over. Plus epsilon 2, 3, 1 into A3, B1 plus epsilon 2, 1, 3, A1, B3 plus epsilon 3, 1, 2 into A1, B2 plus epsilon 3, 2, 1, A2, B1. Now you put the values of plus 1, minus 1 and solve this. Very simple, very simple. What is epsilon 1, 2, 3? It is plus 1 into A2, B3 plus epsilon 1, 3, 2 is minus 1, A3, B2 plus epsilon 2, 3, 1 is plus 1, A3, B1 plus epsilon 2, 1, 3 is minus 1 into A1, B3 plus epsilon 3, 1, 2 is plus 1 into A1, B2 plus epsilon 3, 2, 1 is minus 1 A2, B1. This is nothing but A2, B3 minus A3, B2 minus A1 B3 minus A3 B1 plus A1 B2 minus A2 B1. You just see from the matrix also what is the value we have got? A2 B3 minus A3 B2, first one into I. This is into I. This is into I. This will be multiplied by I. This sequence will be multiplied by J. This sequence will be multiplied by K. This is multiplied by J and this is multiplied by K. Because 1, 2, 3, 1, 3, 2, this combination is multiplied by I. And 2, 3, 1, 2, 1, 3 multiplied by J. It starts with 2 because we have taken here 2 as the initial value. 2 represents J. Here initial value is 1. That represents I. Here initial value is 3. That represents K. Now, what is the final value? A2 B3 into I minus J into A1 B2 minus A1 B2 A2 B3 A3 B2 A3 B1 A1 B3 minus A3 B1 plus A1 B2 minus A2 B1 into K. You just see the value is same, A1 B2 minus B1 A2 into K. This correct. Minus of A1 B3 minus A3 B1, A1 B3 minus A3 B1 into J minus of J. This is correct. Then A2 B3 minus B2 A3. This is also correct. For a simple 3 by 3, from a simple 3 by 3 matrix, for a simple A cross B of 2 vectors, we can easily get the relationship, we can easily get the value by the cross product using the matrices or using the traditional method. But if the relation is like this, if the relation is like this, as I told you, A cross B cross C A cross B cross C, if the relation is like this, here we have checked up. For example, the relation is like this. Question. It is a homework, you please try. But still, I will try to solve this and prove this in only few seconds, not much time. This relation, it may be a complicated relation when we go in the traditional way by using Levicivita symbol definitions. We'll be able to do it very easily. Vector triple product. Vector triple product, which I have told you in the beginning of the class to prove the relation. Prove the relation. This is basic vector triple product. We can ask any type of triple product, double product, cross product, or a mix of cross and dot products in the examination. We are not aware. But any relation that can be predicted, solved and proved by using Levicivita symbol in less than a minute. You need not remember or by heart any relation. You can do it with Levicivita symbol in less than a minute. Vector triple product. Find A cross B cross C. This is the question. Or A cross B cross C is equal to. Prove that. That is equal to B C dot A minus C A dot B. This relation, if the A, B and C values are interchanged and given the alternatives, people get confused. But with the Levicivita symbol relation, along with the Kronecker delta, that epsilon ijk is equal to into epsilon ILM is equal to delta JL into delta KM minus delta JM into delta KL. With this relation or with this relation, we can easily, very easily prove this vector dot product relation. This I will do it in the next class. Now, another small problem I will solve. Prove that A cross A is equal to 0. Can we prove it? How to prove it? Don't go by the definition that A cross A because it is a cross with the same sin theta, sin 0 is equal to 0. That's one method. Using Levicivita. Here we are doing Levicivita and Kronecker delta. What is the definition of A cross B using Levicivita? It is A cross B is equal to epsilon ijk aj bk. From basics, epsilon ijk aj bk is equal to A cross B. Or I can even write epsilon lmn ambn is equal to A cross B. Why I am writing this? You can use any notation. There is absolutely no problem. Epsilon PQR AQBR is equal to A cross B. You use anyone. Let me use with brevity the last one. What is A? A cross A is equal to epsilon PQR AQBR. Then another simple, when the cycle is reversed, what happens? The values get the negative. The values will be negative. Epsilon PQR is equal to plus 1. Let us see. This is 1, this is 2, this is 3, this is P, this is Q, this is R. If the order is reversed, You are keeping this as same. That is equal to minus epsilon PQR AR BQ. What is epsilon PQR AR BQ? This is nothing but minus this, let us say, instead of B A, we can say, let us say, this is A cross B. This is the definition, A cross B minus B cross A. A cross B is equal to minus B cross A. If B is replaced by A itself, then what happens? A cross A is equal to minus A cross A. If B is replaced by A. This is B is replaced by A. This implies 2 into A cross A is equal to 0. This implies A cross A is equal to 0. Here we have not gone into the details of sin theta, cos theta and all this. Using Levicivita symbol, Kronecker delta, we have proved that A cross A is equal to 0. Proved. Now, in the next class, we will try to prove the previous problem. In addition to that, let us try this. Prove that. These are all simple proofs. We can do it bigger proofs in the next following 1 or 2 classes. A cross B dot C cross D is equal to A dot C into B dot D minus A dot D into B dot C. A cross B dot C cross D is equal to, it's a scalar product. These are two vectors. It's a scalar product. That is A dot C is a scalar. B dot D is a scalar. A cross D is a scalar. B dot C is a scalar. But how to put it in this particular sequence? Are we required to remember it? Are we required to by heart it? If you by heart and remember a formula, you will get confused and you will forget it in the examination. Whereas, you use the Levicivita symbol and Kronecker delta relationship, you will be easily able to prove the above theorem. And another also we can prove A dot, this is the second problem we will be proving, and the third problem in the next class we will be proving A dot B cross C is equal to C dot A cross B. Vector triple product, scalar triple product, and another also we can prove vector triple product that I have already written for your this one. This we'll call it as 1. Problem 1, A cross B cross C. Second, A cross B dot C cross D. Third, A dot B cross C. These 3 will take up with the definitions which we have given about Levicivita symbol and Kronecker delta, their combination, their relation in the next class. Best of luck to everybody. It's Ramachandra, an IIT alumni from Civil Maths Concepts, and I give lectures on mathematics for the benefit of UPSC Civil Services, for the benefit of GATE Engineering Mathematics, for the benefit of IIT JEE Advanced and IIT JEE Mains, and for CSIR. Please get benefited out of these lectures, and this is my 15th lecture, and I will be giving lectures one by one. I had already given about some 9 lectures on linear algebra. Please refer to them. Very simple tricks I have provided, and I have given about some 5 lectures on integral calculus, including Leibniz theorem recently, and this is about Levicivita symbol and Kronecker delta for vectors. I felt knowing the linear algebra and definite integrals in integral calculus and vectors now is going to lay a foundation better for differential equations, vector calculus, and complex analysis in future, which are the other topics I will be taking up. Before the GATE examination, I will complete the syllabus. Best of luck to everybody. Please see my other videos also. Review them, comment on them, so that I will improve myself for producing a better lecture for the benefit of everybody. Thank you for listening to me.